Namaskar, my dear friends. So let us talk about how to design microcontroller circuit design or microcontroller based system step by step. So we'll try to understand what are the things that we need to take care of or what are the approach that we should take care of so that we can design a complete microcontroller based system. Okay. So we have already seen the various circuit designs or like concepts of this particular microcontroller, which is MSPM0G series. Okay, and in MSPM0G series 3507 we have taken 64 pin LQFP package. All right, so in this particular session we will start to understand what are the techniques or what is the process that we follow step by step so that we can design a complete system. All right, so let us start by questions. Okay, so basically in terms of microcontroller schematic design, first of all we have to understand what is the design requirement. Okay, like what are the peripherals that will be utilized or what is the application. Understood. And then how we can start, that also we will see, like what is the first step to start with a microcontroller based circuits, and what is the a process or what is the method to design microcontrollers, like what how we can design the symbols, whether it will be a single symbol or heterogeneous symbol like multiple symbols. Based on the number of pins we decide that way, right? And also how we arrange the pins in your like port wise or pin number wise. We try to keep ports together, as well as we try to keep all the power supplies separately. Then what is the approach of circuit designs, and as well as the most important part is how we can assign the pins, okay, for different functionalities, like we have ADCs, then DAC, we have op amps. Let's say we have a lot of various things that we will see one by one. Okay, so as you have already seen, let us say this is the circuit that we have seen. Okay, and we will try to explain you one by one in detail. Like first we take the question and then we come to the circuit. Then it will be bit easier for you to relate. Okay, like how you are going to relate it, so that based on the question you will be able to relate the solution. All right. Okay, so first of all, let us start with microcontroller selection. So based on your design requirement, like how many pins are required or what is the like a company process technology and all those things, based on that you would have designed or you would have selected a microcontroller. Let's stop at that place. Okay, so suppose you have selected a microcontroller which is MSP M0G series 3507. Okay, and it is going to have 64 pin LQFP package. Now we are going to talk about how to program it, how to put a reset button, and how to put decoupling capacitors and power supplies. Okay, so these are the three things that we will try to solve. So to solve these three things, what we can do is come back to the microcontroller page that we are into. Okay, and then for programming part, what we can do is we can think of SWCLK pin and SWDIO pin, and we have a power supply, and then we have a ground. So this is how programming connected is very simple, just by wire, that is two wire symbol. It is more than enough. Okay, and you can connect this SWCLK and SWDIO to your microcontroller pin, which is going to be at this place. Okay, so if you want, you can keep it dedicated and you don't need to put any resistors or anything. And if you want, you can keep it dedicated for your programming purpose. Okay, but the advantage is these two pins can be used as a GPIO pin also. So after programming you can assign these two pins for some other functionalities if you want to. Okay, so programming is done. Now let us say in some cases the microcontroller requires say, like reset or something like that. In that case what we will do is there is a NRST pin. Okay, so this NRST pin will get connected here and it is pulled up so that it will allow the microcontroller to start into the work. Okay, now if you press this particular button, once you press it, what will happen? This will go ground and this is how it will get reset. So you have to give a small amount of time so that it will get resetted. Got it? And then coming back to decoupling capacitors and all, so this is a power supply pin which is VDD. A single pin is there in this microcontroller. So what you have to do is you have to decouple with 10 microfarad capacitors and 0.1 microfarad capacitor. All right. Now there is a internal voltage supply, so that is like around 1.2 volts. So that is going to be internally generated, and you have to just bias with a capacitance of 0.47 microfarad. So this 0.47 microfarad will be used to do that job. Okay, so we are clear with programming, reset and decoupling capacitors. If you wish to, you can have like oscillators also. So I have used like high frequency oscillator and low frequency oscillators, that is 12 megahertz and 32.768 kilohertz. Okay, so you can use these two and you can connect to their respective pin. You can see here we have HFX in, HFX out. So this is for high frequency oscillator, and this is LFX in and LFX out. For RTC applications or something like that, you can use this. Otherwise, you can use internal oscillator of this particular microcontroller as well. So you don't have to use these 4 pins. This 4 pin you can use for some other GPIO purpose or other functionalities. Okay. Good. So let us take another question. So the next question is, no design like is complete without a power supply requirement, right? So any design will need a power supply. So for that you have to first calculate what is the power supply consumption. Okay, so like whether it is 200 milliampere is needed or 100 milliampere is needed total consumption of the system. Okay, like there are a lot of other discrete circuits and your microcontroller and other things are there. So in that case, how much consumption is there, that you have to calculate one by one. Let's say in Excel sheet, or maybe some tools are there which through which you can calculate them. Okay, then voltage labels like voltage rails, so whether it is going to be 5 volt or 3.3 volt, or what are the different voltage levels that you are going to use in your system. Let's say -5 volt is maybe needed or maybe there will be a need of ±7 volt or ±12 volt. What is the need? So here we will be needing only these 2 volt, like 5 volt and 3.3 volt. To bias one op amp we need -5 volt as well, that we'll see later on. Okay, and then in that case we have to understand whether we need to have a switching regulator or linear regulator. So let us say your input is let's say 12 volt. So you can go ahead with switching regulator to convert it to 5 volt, and from 5 volt to 3.3 volt you can convert it through an LDO. Okay, but however, if you need a lower current rating, then instead of switching regulator you can go ahead with LDO as well here. Okay, so from 12 to 5 you can go ahead with LDO also for lower current capacity. All right, so let's solve this problem. So to solve this problem, what we are going to do is you can see let us come down. Okay, so what we have done is we have given a connector so that you can like connect the power supply, DC power supply, DC in, and this can be like let us say 6 volt to up to 15 volt, it will work, not a problem. Or otherwise you can keep a adapter jack as well. So generally these days very like a standard adapter jack is there which is 12 volt 2 ampere rating, or 6 volt 2 ampere rating, or 1 ampere rating. So up to 1 ampere rating you can connect it, not a problem. Okay, now this is a particular linear regulator that has been used, and it is going to give you a 5 volt supply, okay, with 800 milliamperes of output. So based on, let us say you have calculated 100 milliampere of consumption, then you can design your regulator for 300 milliamperes of output current. Okay, so this is how you can understand. Okay, let us say you have calculated 1 ampere of consumption, then you can design for 1.5 amperes of like regulator, or let's say maximum 2 amperes will be sufficient. Okay, similar to that, from this 5 volt we are going to convert it to 3.3 volt. So 3.3 volt, this regulator has been used from ST Microelectronics, and this is having a capability of 500 milliamperes. So your 5 volt will also supply to some discrete supplies, as well as it will supply for the input to this linear regulator. Okay, so my power supply design is also done. So interchangeably this VCC or 5 volt both will be used for your 5 volt application. Similar to that, this VDD and 3.3 volt both will be used for your 3.3 volt applications. Okay. Now let us get into the next question. So next question is peripheral connections. Okay, so let's say we need like a ADC measurement, or like how we can measure some voltage levels or all these things. Okay, so in that case what we can do is we can go into the ADC measurement and let us see what are the things that we can do. So we have 5 volt here and we want to monitor it through that ADC. So what we can do is we can go for voltage division so that we can come to around how much it is, like 10 and 30k. So 5 into 10 by 40. So that you have to understand 10 plus 40. So this is going to be 5 at 40, and then this is going to be 1.25 volt. So 1.25 volt will be appearing here. So you have to make sure that your ADC reference must be more than this. Okay, so that's the understanding you should have. Similar to that, this 3.3 volt VDD is converted to a lower voltage level. So you can see what is the voltage level that you will see at this place. So that will be 3.3 multiplied by 2.2 divided by 4.75 plus 2.2, that is 6.95. And in that case you can calculate this particular voltage. So it will be also like almost half of this, like 1.6 volt or something. So this is how 1.6 will go to the ADC pin. Okay. Now your aim is to find out where ADC are available in your microcontroller. So this is very important question. You can go to like a pin description or signal attributes. I will open and show it to you in the data sheet, like how to like find out your ADC pin very quickly so that you don't make any mistake in assigning the pin numbers. Okay, so you can see here we have ADC value 2 and ADC value 1. So these two pins are used for your 5 volt and 3.3 volt like a measurement. And you can see this is having pin A07 and this is having A01. So A01 channel and A07 channel is going to measure your ADC. So let us say you open the data sheet and you try to identify which pin I should like go to for different functions. Okay, so for that what you can do is you can come to this is the data sheet for MSPM0G3507 series, and you can come to the table of content. This is my table of content that is there on page number 4. So this is the thing, you have pin diagram, you have pin attributes, and you have signal description. So pin attributes can also help you, and signal description is much more convenient. So go to signal description and see how nicely they have arranged the pins for ADC. So you come back to this ADC, then you have 64 pin, 48 pin, 32 pin, 28 pin. So your aim is to go into 64 pin. Okay. So this 64 pin column, you can go ahead and you can take out. Okay. So what you can do, these are the pins like A0 to A7 and 12, and then A1 of 0 to. So there are two ADCs that is available, and you can connect any of the pins for your ADC functionalities. So this is the best approach to find out your pin and assign that. Okay. Now let us get into the next question. So we want to put one alarm buzzer. So alarm buzzer we want to put, or let us say then IR sensor we want to put temperature sensor, we want to put humidity sensor. So these 4 questions we will see together. Okay. So let's get into the question of these things. So as you can see, uh, this is the question. So we have alarm buzzer. So we have like chosen one alarm, that is CST-931 AP. So if you want to have 3.3 volts power supply for this, you can choose 931 AP. If you want to choose 5 volt, then CST-951 AP can be used for 5 volt supply. So you can use here 5 volt. Similar to that, you have to give one PWM signal. So you understand that this input must be coming from the microcontroller PWM signal. Okay, so to assign the particular pin, again you have to go into the pin attributes and find out what is the pin that is going to give you an PWM signal. Okay, got it. Now coming back to the IR sensors, a very simple IR sensor I have used from Visa Semiconductor or Visa Dell. So you can see TSOP 13436. So this is going to get connected and it is going to go to the IR sensor. So it can be given to your ADC or normal interrupt pin, and that can also give you an understanding of that IR sensor has been sensed. Okay. Coming back to the pin photodiode or ambient light sensor. So ambient light sensor has been used. This is again from Visa Dell. So this light sensor will actually give you an understanding of how much light is there outside your environment, and based on that it will generate a signal, and this will be calculated by your ADC, and this ADC will give you an understanding of what is the value of your ambient light, okay, whether it is dark or normal or it is quite bright. So all these things can be taken care. Got it. So let's get into the other part. Okay, we have temperature sensors and humidity sensor. Okay, so in temperature sensor and humidity sensor, what we'll do is we'll go into the sensor page. So this is the sensor page, and this is only one IC, single IC, which is having temperature sensor also, that is VT, and humidity sensor also, that is VRH. So this HS4101 that is taken from Renesas, and Renesas is having this particular IC which is having both the functionality, and now they have been amplified, buffered and amplified and filtered. So there is no amplification right now because it generates enough amount of signal, so there is no need of amplification. If you want, you can amplify as well, then filter and then send it to your ADC. Understood? Similar to that, one more temperature sensor has been used, that is a simple analog temperature sensor. So you give a power supply and it will give you the output based on the temperature. So it is going to give you around 10 millivolt per degree centigrade temperature. So it is 25 degree centigrade, it will give you some voltage, 26, 10 millivolt more, and then you send it to your ADC pin. Okay, so all these ADC pin, you know how to select ADC pin of microcontroller, you connect it to that respective pin. Let us take another question. So another question is, we are going to find out ambient light sensor. So ambient light sensor just now we saw, and along with that we'll see EEPROM. Okay, so EEPROM is basically used to store live data, or we have some memory to store. So in that case, generally people use I2C interface. Sometimes SPI interface is also used for high amount of EEPROM memories or something like that. So in that case, what we'll do is we'll go ahead and see ambient light sensors and EEPROM. So as you can see, this ambient light sensor we already saw. Now come back to the EEPROM part. So this is the EEPROM, okay. So this is having SPI interface. So SPI interface, you can see that we have a channel selection pin, that is CS. Then we have SPI MISO and MOSI lines, okay. So this MISO line and MOSI line is there. And then we have SPI clock line, okay. So MOSI is nothing but your master output slave input, okay, and this is having master input slave output. So this is how it is connected, okay. And then this particular SPI interface EEPROM is actually connected with your power supply and some capacitance, and similar to that, the CS line as well as the write protection line has been pulled up, okay. So if you put a write protection line down, then it will be disabled, like you will not be able to write it, okay. So it is write protected. So if you want to control, you can connect a a microcontroller IO pin in this, okay. So there is a lot of cluttering here, so let me just remove the things a little and you can understand properly, okay. Good. So this was all about the EEPROM with SPI. Then EEPROM one more I have put with I2C. So I2C, you can see I2C signal is coming here, and they have been already pulled up in the microcontroller side. So here there is no pull up resistor put here, and it is also supplied with a power supply capacitance and filter capacitor, and this is how nicely this particular EEPROM has been connected. Similar to that, one more ambient light sensor has been used with I2C interface that I already asked, like showed you. So this is a VEML 6031X01. So VEML 6031X01. So this is from Visa Dell again, or Visa Semiconductor. So this is IC that has been used for your ambient light sensor measurement, and this is having I2C interface. Okay. If you want to reduce the speed, then you can increase this particular resistance value to 4.7 kilo ohm. Okay. Both of them can be increased to that value. And if you want to increase the speed, then keep it 2.2. So 2.2 to 4.7 kilo ohm you can use for that purpose. And this is an interrupt pin which can be pulled up with 10K to 100 kilo ohm. So I have pulled it up with 10 kilo ohm. Good. So hope you have an understanding of like how to start this circuit design, or what are the things that we need to take care of. So there are little more questions that is remaining. Okay. So some 3-4 pages more are there, like LED, push button, dip switches, and all these things, DAC and all. So we'll cover these portions in our next session. However, if you do have any questions regarding this, like up to this step, then you can put down your questions in the comment box, and we will be able to give you a much elaborate answers. Or if you wish to understand it more deeply, like how to start the circuit design in like OrCAD, and how to put all the circuits properly, like how to move it up and down or something like that. So all these things you can do by joining our course. So if you wish to like learn much better, you can join our course, and you can understand how to nicely like construct your circuit, make your symbols, and all these things. Okay. So thank you guys.